Hi everyone. Today we'll talk about limits of functions involving absolute value. First, we must understand what absolute value is. So, I have an exercise. We have two functions, f of x and g of x. The function f of x is the absolute value of x. The function g of x is the piecewise defined function on the right side. I want us to first compute the values of these two functions at the 5 given inputs. If you would like to try this exercise on your own first, you can download these notes using the link in the video description. I start with the absolute value function. The absolute value of 2 is 2. Absolute value of 1 is 1. The absolute value of 0 is 0. Absolute value of negative 1 is 1. Absolute value of negative 2 is 2. On the right side, I have the piecewise defined function. That function has two formulas. X for x is bigger than 0, bigger equal to 0, and negative x for x is less than 0. 2, 1, and 0 are all bigger equal to 0. For all of those inputs, I will use the top formula. So the value at 2 is 2, the value at 1 is 1, the value at 0 is 0. Things change at negative 1. Negative 1 is a negative input, so I'm using the bottom formula. When I plug in negative 1 to this expression, I get negative 1, which gives me 1. When I plug in negative 2 to this expression, the same thing happens. Negative 2 gives me 2. Note that the expressions, the values in the first column, are exactly the same as the outputs in the second column. That is because the function absolute value of x and the function on the right side, the piecewise defined function, are the same function. In fact, the absolute value function is often defined using this piecewise defined function. That is exactly what the next definition is saying. It says that the absolute value of x is given by this piecewise defined function. The advantage of this definition is that it allows you to rewrite absolute value without absolute value signs. For example, the absolute value of 7, you can simply write as 7. The absolute value of 8, you can simply write as 8. However, instead of writing absolute value of negative 7, what you can do is you can put a minus sign in front of negative 7. That will give you negative 7, which is 7. To rewrite the absolute value of negative 8, you can just write negative 8. This will be very helpful to us when it comes to computing limits of expressions that involve absolute value. If you would like to try this problem on your own first, this will be a good time to stop the video. We must find the limit of the expression absolute value of x minus 2. The first step in computing such limits is to rewrite this expression without absolute value. So I will say that this is the limit as x goes to 3, and now I need to ask myself, as inputs get closer and closer to 3, what happens to x minus 2? Is that number positive or is that number negative? What are some x's close to 3? Like 2.9 is close, or 3.1. When I plug in 2.9 to this expression, the expression inside of the absolute value will be positive. When I plug in 3.1 to the expression inside of the absolute value, that expression is also positive. That means that as x's get closer and closer to 3, the values inside of the absolute value are always positive. According to my formula, if the values inside of the absolute value are positive, I don't need the absolute value sign. So I can simply write it as the limit of x minus 2. Now plugging in 3 to this expression gives me 3 minus 2, which is 1. So the limit as x approaches 3 is 1. Let's try to compute the next limit. Again, the same expression, x minus 2 inside of the absolute value. This time I'm approaching 1. So I'm using numbers such as 0.9 or 1.1. When I plug in 0.9 to the expression inside of the absolute value, I get a negative number. When I plug in 1.1, I also get a negative number. So that means for inputs close to 1, the expression inside of the absolute value is negative. So to rewrite this without the absolute value, I will say that this is the limit as x goes to 1 of negative and just regular parentheses x minus 2. I follow the piecewise defined formula. For x's that are less than 0, I just simply put a negative sign in front of what's inside of absolute value. I apply the direct substitution property, plug in 1, and I get negative 1 minus 2. 1 minus 2 is negative 1. Negative negative 1 gives me 1. I have one more problem for us to try. If you would like to try this problem on your own first, again, you can stop the video now. First, I must find the limit of this expression as x goes to 3 from the right. The first step is to rewrite the expression so that it doesn't have absolute value anymore. So, I ask myself, as I'm using x's close to 3 on the right side, will the expression inside of the absolute value be positive or negative? A typical input on the right side of 3 is 3.1. When I plug in 3.1 here, I get a positive number. So that means I don't need that absolute value in the numerator, and I can simply write it down as x minus 3 divided by x minus 3. Now, x minus 3 divided by x minus 3 is just 1. So this is the limit as x goes to 3 from the right of 1. The limit of a constant function is that constant function. Let's take a look at the limit as x approaches 3 from the left. I again first rewrite the expression without absolute value. As I'm approaching 3 from the left, I'm using inputs slightly less than 3, for example 2.9. If I plug in 2.9 to the expression in the numerator, inside of the absolute value I will get a negative number. So to rewrite this absolute value without absolute value signs, I simply write negative x minus 3 divided by x minus 3. Now I see that x minus 3 in the numerator and in the denominator cancel out. I can divide them out, which leaves me with the limit of negative 1. The limit of a constant is that constant, so I get negative 1. The limit from the right of this expression was 1. The limit from the left of that expression was negative 1. Those two limits are different, so the general limit does not exist. One more exercise. I have a limit of the expression involving absolute value. We see that something special happens at x equal to negative 5. If I'm using x is slightly bigger than negative 5, such as negative 4.9, what I get inside is positive. If I use numbers slightly less than negative 5, like negative 5.1, I will get numbers that are negative. So to rewrite this expression without absolute value, I have to consider two limits, from the left and from the right. I take the limit as x goes to negative 5 from the left of the expression. To rewrite the expression without the absolute value, I ask myself, if I use x's less than 5, will I get a positive number inside of the absolute value or a negative number? If I have negative 5, the numbers slightly less than negative 5 are negative 5.1. When I plug in negative 5.1 to this expression, I will get a negative number. So, to rewrite this expression without absolute value, I will say negative x plus 5. Now I see that if I plug in negative 5 to the numerator and to the denominator, I will get 0 divided by 0. So I apply first an algebraic manipulation. In the numerator, I see that I can factor 3 out of both expressions. This allows me to cancel x plus 5 in the numerator and in the denominator, or rather, to divide it out. That gives me the limit as x goes to negative 5 from the left of 3 divided by negative 1, which is negative 3. The limit of a constant is a constant, so I get negative 3. Now let's compute the same limit, but this time from the right. So I say now the limit from the right. And I ask myself, as I'm using x is slightly bigger than negative 5, will the expression in the denominator, or the expression inside of absolute value, be positive or negative? And I believe, as I'm using x is slightly bigger than negative 5, for example, negative 4.9, then the expression inside of the absolute value is positive. So I don't need the absolute value. I can simply write it as x plus 5. I follow the same procedure as before. I factor the numerator, so I take 3 out of both terms. I see that x plus 5 now divides out, and we get the limit as x goes to 5, or x goes to negative 5 from the right of 3. This is a constant. Limit of a constant is always that constant. The limit from the left was negative 3, the limit from the right was 3, which says that the general limit does not exist.